The United States has initiated the development of a weapon system that represents the most ambitious aviation project since the 1980s and carries implications far beyond military technology. The Boeing F-47 is now moving from theoretical concepts into actual hardware production at speeds that have surprised even optimistic Pentagon planners. More significantly, the revolutionary engine technology powering this extraordinary aircraft has begun demonstrating capabilities that fundamentally transform what jet aircraft can accomplish. How did the United States accelerate the F-47 from conceptual design to production status in just a few years? What makes the variable cycle engines so revolutionary? Join us as we examine the F-47 and its revolutionary propulsion system and assess how this aircraft will reshape the future of air dominance. The F-47 began with secret experimental platforms that have been testing the boundaries of aviation technology for years. The Next Generation Air Dominance Initiative traces its origins to the 2010s, when Pentagon planners recognized that American air superiority, assured since the Vietnam War era, faced unprecedented challenges from emerging peer competitors. China was rapidly modernizing its air force, developing new fifth-generation fighters, and beginning research into sixth-generation platforms. Russia, despite economic constraints and technological limitations relative to the West, was pursuing advanced fighter development, including the Su-57. The European nations also continued upgrading existing fighters, but showed little interest in funding an entirely new generation of combat aircraft. More fundamentally, planners recognized that the F-22 Raptor, introduced in 2005 and still the world's most capable air superiority fighter, was approaching the technological plateau of its generation and would require succession planning within 15 to 20 years. The Defense Advanced Research Projects Agency, or DARPA, launched the Aerospace Innovation Initiative in 2014 to conduct research into the technologies that would eventually define a sixth-generation fighter. Rather than requesting concepts and designs, DARPA funded the development of full-scale experimental aircraft, or X-planes, that would prove out the most challenging technological elements under real-world flight conditions. Multiple contractors, including Boeing, Lockheed Martin, and Northrop Grumman, participated in developing competing demonstrator aircraft. These X-planes were not intended to be production prototypes, but rather technology demonstrators designed to explore concepts that had never been tested operationally. The impact of these demonstrators proved transformational. According to senior Air Force officials, the DARPA X-planes flew hundreds of hours during the NGAD evaluation, testing cutting-edge concepts and proving that the Pentagon could push the technological envelope with confidence. Former Air Force Chief of Staff General David Alvin stated in September 2025 that, "For the past 5 years, the X-planes for this aircraft have been quietly laying the foundation for the F-47, flying hundreds of hours, testing cutting-edge concepts, and proving that we can push the envelope of technology with confidence." At least one DARPA demonstrator began flying as early as 2019, meaning that the experimental aircraft had flown for nearly a decade by the time Boeing was selected to build the production F-47. In March 2025, President Donald Trump personally announced that Boeing had won the competition to develop the manned component of the NGAD program, an announcement that generated extraordinary attention and represented a turning point in the program's trajectory. The decision to award the contract to Boeing reflected multiple strategic considerations. First was the imperative to maintain industrial-based diversity in American defense manufacturing, as Lockheed Martin dominated fighter production through F-35 sales, while Northrop Grumman focused on the B-21 Raider program. Second was program maturity and risk reduction. Boeing's design was built upon years of X-plane testing that had de-risked the most critical technological elements. Third was the Trump administration's emphasis on speed. With China and Russia both pursuing sixth-generation fighter development, the Air Force and Department of Defense recognized that accelerating the F-47 timeline was essential to maintaining American technological superiority. The contract award included significant concessions that accelerated the program's progress. Rather than following the traditional evolutionary path where designs are tested extensively before entering production, Boeing moved directly into engineering and manufacturing development with the first aircraft already in production by late 2025. Boeing CEO Steve Parker stated that the F-47's production represented a testament to the maturity of our design and pedigree coming off the prototype. The company emphasized that it had leveraged years of experimental aircraft development to arrive at a production-ready design, eliminating the developmental delays that typically characterize first-of-a-kind military aircraft programs. The fiscal year 2026 defense budget reflected this prioritization. The Air Force allocated $3.5 billion to F-47 development, with an additional $900 million approved through reconciliation, giving the program a combined $4.4 billion boost. This represented a dramatic increase compared to previous budget cycles and demonstrated that Pentagon leadership considered the F-47 to be critical for maintaining American air superiority. Across the entire life cycle of the program, Boeing was expected to receive hundreds of billions of dollars in orders as the Air Force planned to acquire at least 185 F-47 aircraft, supplementing them with up to 1,000 collaborative combat aircraft, or CCA, autonomous drones that would operate as loyal wingmen. The timeline for the F-47 is extraordinarily aggressive, even by modern military aviation standards. The Air Force announced that the first flight would occur sometime in 2028, with operational capability anticipated before the end of the Trump administration's term on January 20, 2029. This compressed schedule required advances in multiple technological domains simultaneously and demanded that supplier industries deliver components and assemblies on accelerated schedules. Boeing invested heavily in its St. Louis production facility, where the F-15EX and T-7A Red Hawk trainer aircraft were already being manufactured. The company emphasized that digital twin modeling technology allowed engineers to predict manufacturing issues before physical testing began, theoretically compressing development and production timelines. However, the most critical element limiting the F-47's development trajectory is not the airframe itself, but rather the engines powering it. The Next Generation Adaptive Propulsion Program, initiated years before NGAD became publicly discussed, is developing variable cycle jet engines that represent a fundamental revolution in jet propulsion technology. Two companies, General Electric Aerospace and Pratt & Whitney, are competing to deliver the NGAP engines that will power the F-47. The competing designs, designated the GEXA-102 and the Pratt & Whitney XA-103, represent the first operational deployment of variable cycle engine technology in a fighter aircraft. Variable cycle engines function on a principle fundamentally different from all conventional jet engines. Traditional turbofan engines have fixed geometry inlets and cores that cannot change during flight. The engine operates either in an optimized condition for subsonic cruise or for supersonic dash, but cannot simultaneously optimize for both regimes. Variable cycle engines incorporate a third airstream that can be opened or closed based on mission requirements. During subsonic cruise, the third stream remains open, directing cool air through the engine, thereby maximizing fuel efficiency and range. The same engine can then close the third stream, increasing airflow and thrust to achieve speeds exceeding Mach 2 for supersonic operations. The benefits of this technology are profound. The third stream of cooled air open for subsonic cruise theoretically doubles the range of the F-47 compared to contemporary engines used in the F-22 Raptor. The aircraft would be capable of flying intercontinental distances without refueling, projecting American power into contested regions and sustaining operations far from vulnerable logistics bases. Simultaneously, by closing the third stream for supersonic dash, the engines can deliver thrust exceeding 30,000 pounds per engine, sufficient to accelerate the F-47 to speeds exceeding Mach 2, while maintaining stealth characteristics and carrying substantial weapons payloads. The technical challenges involved in developing variable cycle engines are immense. The engine must maintain structural integrity across an enormous speed and power envelope, with components subject to extreme thermal stresses that would destroy conventional materials. The variable geometry must operate reliably through thousands of flight cycles without degrading. The control systems must respond instantaneously to pilot commands, transitioning from one configuration to another without stalling or experiencing compressor surge that could damage the engine. The compressor and turbine blades must be fabricated from advanced materials and coatings that can withstand temperatures exceeding 1,500 degrees Celsius while maintaining dimensional precision measured in fractions of millimeters. Despite the extraordinary challenges, both General Electric and Pratt & Whitney reported remarkable progress throughout 2025. Publicly available information indicates that both engines have undergone initial ground testing and component-level demonstration. GE Aerospace reported testing of the variable geometry inlet system and high-pressure compressor stages. Pratt & Whitney similarly disclosed component-level successes in variable cycle operation. The companies announced plans for full-scale engine testing to commence in 2026, with the expectation that engines would be available for aircraft integration by 2028, aligned with the planned first flight of the F-47. However, Pentagon officials acknowledged that the NJAP engines are operating on a timeline approximately 2 years behind original projections. The delay reflects supply chain constraints that have affected the entire aerospace and defense industrial base since the end of the COVID-19 pandemic. Critical materials, specialized manufacturing equipment, and highly skilled workers remain in short supply, and the combination of simultaneous high-priority programs, the F-47, B-21 Raider, and advanced unmanned systems development, has created severe competition for limited industrial capacity. The Trump administration's response to these delays exemplified the priority placed on accelerating the F-47 program. In late 2025, the Department of Defense initiated expedited reviews of supply chain bottlenecks and authorized exception procedures that allowed contractors to source components outside normal competitive procurement channels if it would accelerate development. The administration allocated emergency funding to expand manufacturing capacity at critical suppliers, including facilities producing advanced composites, titanium forgings, and specialized avionics components. Secretary of Defense Pete Hegseth emphasized that the accelerated timeline for the F-47 reflected the urgency of responding to Chinese military advancement and the absolute necessity of ensuring American technological superiority in air combat. The strategic implications of the F-47 and its variable cycle engines extend far beyond the aircraft itself. The first flight projected for 2028 would demonstrate capabilities that no other nation has achieved operationally. The aircraft would fly faster, farther, and with greater stealth than any existing fighter, while operating in coordination with autonomous drone wingmen that multiplied its combat power. The ability to operate across intercontinental distances without refueling would allow forward deployment into the theater in times of crisis without reliance on vulnerable logistics bases or aerial refueling, eliminating a key vulnerability of current fighter aircraft. The variable cycle engines would establish the United States as the leader in a new generation of propulsion technology that other nations would require years or decades to replicate. Russia, despite possessing theoretical knowledge of variable cycle engine principles, lacks the industrial capacity and manufacturing expertise to produce them. China, while advancing rapidly in aviation technology, has not publicly acknowledged research into variable cycle engines and would face formidable technical challenges in developing competitive systems independently. The NGAP engines would represent a decisive technological advantage that extends American air superiority decades into the future. The F-47's development also reflects a broader shift in how the Pentagon approaches cutting-edge weapons development. Rather than following the traditional path of extensive analysis, concept refinement, and then production, the Trump administration and Air Force leadership embraced an accelerationist approach that moved from prototype testing directly into production with compressed development timelines. This philosophy mirrors the operational approach championed by Secretary of War Pete Hegseth and called the Arsenal of Freedom, which emphasizes speed of innovation and rapid fielding of capabilities over lengthy analysis and risk mitigation. The risks inherent in this compressed timeline are not trivial. Accelerating development timelines increases the likelihood of technical setbacks that could delay the program. Rushing production before all developmental testing is complete could result in design flaws that require extensive rework. The pressure to meet aggressive schedules could result in quality shortcuts or component failures that compromise aircraft safety. Military programs that move too rapidly without adequate testing have historically encountered severe technical problems that ultimately cost more money and time to resolve than would have been required if they had proceeded methodically. However, Pentagon planners calculated that the strategic risks of moving too slowly outweighed the risks of acceleration. Chinese development of sixth-generation fighters, currently projected to reach operational capability in the mid-2030 decade, but potentially sooner, would create a period in the early 2030s where Beijing might possess modern sixth-generation fighters, while the United States still relied on aging fifth-generation platforms. By compressing the F-47 timeline, the Air Force aimed to achieve initial operational capability before China fielded competing sixth-generation systems, maintaining American air dominance through the critical period of the 2030 decade. The relationship between the F-47 and the Navy's parallel sixth-generation fighter program, designated the F/AXX, added another dimension to the timeline acceleration. The Navy competition was slated to select a contractor in 2027, but the focus and resources directed toward the Air Force F-47 program raised questions about whether simultaneous development of two sixth-generation fighters was feasible. Pentagon officials acknowledged that developing both the F-47 and F/AXX programs competed for the same specialized engineers, advanced materials, and manufacturing capacity. Some analysts suggested that a variant of the F-47 might ultimately serve as the Navy's sixth-generation fighter, reducing the technological redundancy and streamlining development and production. The cooperative element of the NGAD program, the integration of the F-47 with autonomous drone wingmen or collaborative combat aircraft, added additional complexity to development. The CCA program received increased funding in the fiscal year 2026 budget, rising from $494 million to $807 million. These autonomous aircraft, designed to operate under the control of F-47 pilots as loyal wingmen that could carry sensors, weapons, or electronic warfare equipment, would multiply the combat power of the manned fighter. Development of the control software, sensor fusion systems, and human-machine interfaces necessary for effective manned-unmanned teaming added significant technical challenges beyond the F-47 airframe and engines alone. Looking forward, the successful first flight of the F-47 in 2028 would represent a watershed moment in aviation history. The aircraft would demonstrate that the United States had successfully transitioned from fifth-generation to sixth-generation fighter development and could field operationally deployed combat aircraft incorporating revolutionary propulsion technology. The variable cycle engines, once proven in flight, would establish a new technological baseline that would guide propulsion development for decades. American fighter pilots would soon operate an aircraft that could engage adversaries at ranges, speeds, and with stealth characteristics that made traditional air combat doctrine obsolete. The implications for Chinese and Russian air forces were profound. China's most advanced operational fighters, the J-20 Mighty Dragon and the emerging J-35, would be rendered technologically inferior to the F-47. Russia's Su-57 would face similar disadvantages. The development of sixth-generation fighter technology in the United States would re-establish the technological superiority that had been the foundation of American air dominance since the Vietnam War era, ensuring that American pilots could defeat any adversary in sustained air combat, regardless of numerical disadvantage. However, the timeline remains contingent on the successful resolution of multiple technical challenges. The variable cycle engines must complete testing on schedule and demonstrate reliability in flight operations. The airframe must successfully integrate with the engines, flight control systems, and avionics without encountering insurmountable integration challenges. The autonomous drones and control systems must function reliably under diverse operational conditions. Any significant technical setback in any of these areas could delay the program and potentially threaten the accelerated timeline that the Trump administration had prioritized. The competition between General Electric Aerospace and Pratt & Whitney for the NGAP engine contract adds an additional dimension of urgency. The contractor that successfully delivers the first operational variable cycle engine will establish itself as the leading supplier for a technology that will power military aircraft for decades. Victory in this competition will bring substantial long-term revenue and position the winner as the premier engine manufacturer for next-generation combat aircraft globally. The company's commitment to meeting schedules reflects recognition that delays could be strategically catastrophic and commercially devastating. The F-47's advanced capabilities would strengthen American alliance relationships and reassure regional partners of the credibility of American security commitments. Japanese, South Korean, and Australian military planners would gain confidence that American military superiority in the Pacific would be maintained into the next decade, reducing pressures on these allies to develop independent strategic nuclear capabilities or pursue strategic accommodations with China. The aircraft's capabilities would also provide psychological deterrence value. The mere existence of an aircraft with the F-47's capabilities, capable of operating across intercontinental distances, achieving supersonic speeds, and maintaining stealth characteristics while carrying substantial weapons payloads, would demonstrate American technological superiority in a way that influences adversary calculations and deterrence judgments. The F-47's development also reflects a broader shift in how the Pentagon approaches cutting-edge weapons development. Rather than following the traditional path of extensive analysis, concept refinement, and then production, the Trump administration and Air Force leadership embraced an accelerationist approach that moved from prototype testing directly into production with compressed development timelines. This philosophy mirrors the operational approach championed by Secretary of Defense Pete Hegseth and called the Arsenal of Freedom, which emphasizes speed of innovation and rapid fielding of capabilities over lengthy analysis and risk mitigation. This represents a fundamental departure from the approach that dominated Pentagon acquisition policy for decades. Traditional military development followed a series of phases: conceptual development, technology demonstration, competitive evaluation, engineering and manufacturing development, limited production for testing, and then full-rate production. Each phase included extensive testing, evaluation, and risk mitigation. Problems discovered in one phase would be corrected before proceeding to the next phase. The accelerationist approach, by contrast, accepts higher technical risk in exchange for faster fielding of capabilities. Rather than exhaustively testing designs before committing to production, the F-47 program moves directly to production with testing and development occurring in parallel. Rather than waiting for the most optimal design solution, the program accepts good enough solutions that can be delivered on accelerated timelines. China's giant aircraft just stunned the world. Most people did not expect China to achieve this, but they proved everyone wrong. This has surprised American engineers and prompted experts to take a fresh look at what the country can achieve in aerospace. This aircraft stands out due to its size and capabilities, and it's changing how people perceive China's technical abilities. What exactly makes this aircraft so noteworthy, and why are industry experts suddenly paying closer attention to China's aerospace progress? Join us as we examine the key details behind this development that's making headlines across the aviation world. In aviation, size is more than just appearance. It determines cargo capacity, flight range, and overall performance. Building these massive planes is one of the most complex engineering challenges, requiring advanced technology, structural strength, and precision. Countries worldwide have pushed the limits to create larger, more capable aircraft, but China's progress in this field has drawn significant attention. The Xi'an Y-20 Kunpeng, China's largest domestically produced military transport aircraft, has become a key symbol of its growing presence in global aviation. The Y-20 Kunpeng is built for serious transport. It is about 154 feet long, with a wingspan of roughly 164 feet, and it can handle a maximum takeoff weight of around 486,000 pounds. This aircraft is designed to move heavy cargo up to 66 metric tons, including troops, tanks, and essential equipment over long distances. Its development marks a major step for China's military logistics, providing a reliable, domestically produced transport that enhances mobility and response capabilities both within the country and on the global stage. What makes the Y-20 remarkable is not just its size, but what it represents. This aircraft showcases China's ability to design and manufacture advanced aviation technology, marking a huge step forward in its aerospace capabilities. With the Y-20, China has developed an aircraft that matches the scale and capabilities of some of the world's largest military transports, positioning itself alongside global leaders in air power. The Xi'an Aircraft Industrial Corporation built the aircraft. This military transport plane was designed to move heavy cargo over long distances. Its name, Kunpeng, comes from an ancient Chinese myth about a giant fish that turns into a massive bird. But within China's aviation industry, it is casually called Chubbil because of its noticeably wider body, giving it a unique, stocky appearance that makes it stand out on the runway. In 2013, the Y-20 aircraft had an estimated price tag of about 160 million United States dollars. For comparison, that is roughly half the cost of its American counterpart, the Boeing C-17 Globemaster III, which was priced at around 340 million United States dollars in 2022. This price difference highlights China's increasing competitiveness in developing large-scale military aircraft. The Y-20 was built to meet a crucial need for China's military, providing fast and efficient transport for troops, vehicles, and supplies over long distances, similar to how major world powers use their heavy cargo planes. The project started in July 2007, and by the end of 2012, early images of its prototype were already circulating online. Its first flight happened on January 26, 2013, marking a significant milestone for China's aviation industry. One of its most groundbreaking features was its use of advanced technology. Reports from China indicate that it was the first cargo aircraft to incorporate three-dimensional printing in the production of its parts. This innovation helped streamline manufacturing, reduce workload, and cut costs, giving China a major advantage in building such a sophisticated aircraft. The Y-20 project team adopted a modern approach to accelerate design and enhance precision, utilizing model-based definition. Instead of traditional paper blueprints, engineers created fully digital models, making the process more efficient and streamlined. What makes this stand out is that the Y-20 was only the third aircraft in the world to use this system, following the Airbus A380 and Boeing 787. By integrating advanced tools like 3D printing and model-based design, China not only built large aircraft, but also advanced aviation technology. Traditionally, installing a plane's wings can take up to 2 months, but with MBD, this process was reduced to just a few hours. Overall, design time was cut by 40%, production preparation shrank by 75%, and the whole manufacturing cycle was shortened by 30%. Structural tests that were initially planned to take 300 days were completed in just 194 days, significantly faster than earlier projects like the Xi'an JH-7, which took a full year for similar work. Beyond MBD, the Y-20 was the first Chinese aircraft to incorporate a relational database management, or RDBM system. Deputy General Designer Feng Jun and the team faced early challenges, failing their first attempt after 2 months of work on the nose section. Their second effort, focused on the wings, proved successful after 3 more months. This breakthrough shaved at least 8 months off the overall development timeline, with some design adjustments, such as wing modifications, reducing the work time from a whole week to just half a day. The Y-20 also uses virtual reality technology in its development. Pilots and engineers use specialized helmets to interact with the aircraft's systems in a virtual environment, allowing them to test functions and identify issues before physical construction begins. This approach improves efficiency and reduces costly errors. Unlike earlier projects that depended on imported materials, the aircraft is built using advanced composite components made entirely in China. This includes specialized relays developed by Guilin Aerospace, part of the Tri-River Aerospace Group, and flame-retardant materials from the 703 Institute of the China Aerospace Science and Technology Corporation. These high-performance composites meet global safety standards, demonstrating that China is not only keeping pace in aerospace material science, but is also actively competing on the world stage. The cargo design is built for efficiency and flexibility. It features a wide shoulder wing, a tall T-tail, and a large rear ramp that makes loading military vehicles and heavy machinery much easier. The landing gear is designed to handle serious weight with 3 rows of wheels on each side, totaling 12. This setup keeps the plane stable even on rough runways. According to the aircraft's deputy general designer, it can take off in as little as 600 to 700 meters, about 2,000 to 2,300 feet, making it a highly adaptable option for military operations and disaster relief missions. The Y-20's cockpit is equipped with 4 large liquid crystal display electronic flight instrument systems, or FIS screens. Instead of traditional dials, these digital displays provide pilots with real-time data, making it easier to monitor the aircraft's performance. This upgrade enhances safety and efficiency, enabling quicker and more informed decision-making during flights. Combined with its advanced materials and durable construction, the Y-20 isn't just a transport aircraft, it is a powerhouse. The aircraft initially relied on 4 Russian Soloviev D-30KP-2 engines, each providing about 12 tons of thrust. These engines powered the plane when it officially entered production in 2016. However, from the outset, China had grander plans, developing engines that could match or even surpass those of foreign models. This was not just about technological advancement. It was about reducing reliance on imported systems and strengthening national aerospace capabilities. By late 2017, China had started testing the Chengdu WS-18 engine, a domestically produced version based on the Russian D-30. The WS-18 was about 300 kilograms lighter, weighing just under 2 metric tons. It generated slightly more thrust, around 13 tons per engine, and was more fuel efficient than its predecessor. To put it in perspective, it is like upgrading from an older, fuel-hungry car to a newer, more efficient model with a bit more speed. While the improvement was not dramatic, the WS-18 served as an interim solution as China continued to develop a more advanced engine. The Shenyang WS-20 was the advanced engine China had been working on. It provided power to give the Y-20 the boost it needed. Each engine produced about 14 tons of thrust, allowing the aircraft to carry up to 66 tons of cargo, which is roughly the weight of 100 fully loaded pickup trucks. Using the same core design as China's WS-10 fighter jet engine, the WS-20 began single-engine testing in early 2019. By late 2020, China was already running complete flight tests with all 4 WS-20 engines, pushing the Y-20 to its limits. In March 2023, the upgraded Y-20B, equipped with the long-anticipated WS-20 engines, entered service with China's People's Liberation Army Air Force. That same month, the Aero Engine Corporation of China confirmed it had resolved all significant technical challenges with engines like the WS-20. This milestone signaled a shift for China's aviation industry, proving it could not only match but surpass older foreign designs and establish itself as a global contender. On July 6, 2016, China officially delivered its first mass-produced Y-20 aircraft with serial number 11051 to the People's Liberation Army Air Force. Shortly after, the second aircraft, numbered 11052, was assigned to the 12th Regiment of the 4th Transport Division in Chonglai, Chengdu. This was a major milestone for China's military aviation, proving that these aircraft weren't just being built, they were entering active service with a clear purpose. By May 8, 2018, the Y-20 was no longer just sitting in hangars. The People's Liberation Army Air Force confirmed that the aircraft had completed its first joint airdrop training with airborne troops. This marked an important step in its operational use, as China was now using the Y-20 for more advanced military missions. Training exercises focused on deploying troops and equipment into battle zones, a critical capability for any major air force aiming to respond quickly and effectively. In February 2020, as the COVID-19 pandemic unfolded, the Y-20 was deployed for an entirely different kind of mission. On February 13, it joined a fleet of 11 aircraft delivering 2,600 military medical personnel to Wuhan, the heart of the outbreak. The fleet consisted of 6 Y-20s, 3 Ilyushin Il-76s, and 2 Y-9s. This marked the Y-20's first civilian operation, proving that military transport aircraft aren't just for combat, they can be vital in disaster response as well. In the years that followed, the Y-20 continued to expand its role. In June 2021, it was seen patrolling over the South China Sea, drawing criticism from Malaysia, while Japanese analysts viewed it as a sign of China's increasing air power. Then, in November 2021, a Y-20U aerial tanker was spotted near Taiwan, marking its first documented operation outside mainland China. By January 2022, two Y-20s flew over 10,000 kilometers from Guangzhou to Tonga, delivering 33 tons of disaster relief after a volcanic eruption and tsunami. From military exercises to humanitarian missions, the Y-20 has become a symbol of China's growing global presence. On April 9, 2022, 6 Y-20 cargo planes landed at Belgrade Nikola Tesla Airport in Serbia, reportedly delivering Fk-3 surface-to-air missile systems. This event underscored the Y-20's role in China's global military exports. For those unfamiliar with military transport, these planes are like enormous flying trucks that deliver advanced missile systems designed to strengthen a country's defenses. On June 28, just a few months later, 6 Y-20 aircraft arrived in Afghanistan, delivering 105 metric tons of humanitarian aid after a devastating earthquake. To put that into perspective, it is about the same weight as 70 fully loaded family cars packed with supplies. This mission was not about military strength or defense. It was purely about helping people in need. The Y-20's ability to shift between military operations and humanitarian relief shows how China is using its air force for more than just national security. It is also playing a role in global crisis response. On August 1, 2022, China introduced the YY-20, a tanker variant of the Y-20, and announced that it had started combat readiness training. Aerial tankers like the YY-20 are essential for refueling fighter jets in mid-air, allowing them to stay airborne longer and cover more ground. This is like a race car getting refueled without stopping. It keeps the jets flying without interruptions. The following September, China released video footage showing YY-20 tankers refueling Chengdu J-20 stealth fighters, confirming that the system was fully operational in real-world conditions. The Y-20 made its first public appearance at a Western European air show in early September 2022, showing up at Air Power 2022 in Austria. This was a significant moment for China, as it demonstrated the country's advancements in military aviation on an international stage. Since then, China has developed several versions of the aircraft. The Y-20A, powered by either Russian or Chinese engines, the Y-20B, equipped with the stronger Shenyang WS-20 engines, and tanker variants like the YY-20A and YY-20B, which can carry about 90 metric tons of fuel, comparable to Russia's Ilyushin. There is even an airborne early warning version called the KJ-3000, which was spotted undergoing flight tests in late December 2024. On July 13, 2016, Chinese national Su Bin admitted to helping hack into Boeing systems. The goal was to steal classified documents on 3 of the United States' most advanced aircraft: the C-17 cargo plane, the F-22 stealth fighter, and the F-35 fighter jet. Once the data was taken, Su Bin translated the files from English to Chinese and sent them to the 2nd Department of the People's Liberation Army General Staff Department. In simple terms, he was acting as a go-between, funneling critical U.S. military intelligence to China, all for personal profit. Su Bin was not just after money. He admitted in his emails that the stolen data was crucial for accelerating China's military projects, particularly Project A, which later turned out to be the program behind the Xi'an Y-20 cargo aircraft. By passing along this intelligence, he gave China a shortcut in developing a transport plane that could rival U.S. capabilities. He was sentenced to 3 years and 10 months in federal prison and fined $10,000. But after serving part of his sentence, he was released by October 2017. This case became a clear example of how cyber espionage can rapidly advance military technology and influence global defense dynamics. The Xi'an Y-20 became one of China's most powerful military cargo planes, built to transport massive loads over long distances. It operates with a crew of 3 and can carry up to 66,000 kilograms. That is roughly the weight of 50 compact cars, or over 140,000 pounds. The aircraft itself is about 47 meters long, with a wingspan of 50 meters and a height of 15 meters. To put that into perspective, it's as tall as a 5-story building, and its wings extend more than half the length of a football field. The Y-20's capability comes from its 4 turbofan engines, each producing 140 kilonewtons of thrust, about 31,000 pounds of force. That is like having 4 massive rockets under the wings, working together to get this aircraft off the ground. Despite its empty weight of 100,000 kilograms, it can take off at a maximum weight of 220,000 kilograms, more than twice its weight. The Y-20 delivers solid performance, reaching a top speed of 926 kilometers per hour, about 575 miles per hour, or Mach 0.75. For standard flights, it cruises at around 630 kilometers per hour, or about 390 miles per hour. Its range is what stands out. It can fly up to 7,800 kilometers while transporting 2 Type 15 tanks. If it's carrying a lighter load of around 16.5 tons, its ferry range stretches to 10,000 kilometers, making it a competent long-distance transport aircraft. The rival of the Y-20 is the C-17 Globemaster III, which is a heavy-duty military transport aircraft designed for big missions. Operated by a crew of 2 pilots and 1 loadmaster, it can haul up to 77,000 kilograms of cargo, that is about 170,000 pounds, loaded onto 18 military pallets. But it's not just built for freight. It can carry over 100 paratroopers, seat 134 soldiers with gear, or 54 troops when maximizing cargo space. On medical missions, it can transport 36 stretcher patients, plus 54 walking patients and medical personnel. This aircraft is built to move serious weight, whether it's an M1 Abrams tank, 2 Bradley armored vehicles, or 3 Stryker armored vehicles. The C-17 is built for serious heavy lifting. It measures 53 meters in length, has a wingspan of about 52 meters, and stands nearly 17 meters tall, roughly the height of a 5-story building. Its wings span 350 square meters and use a specially designed airfoil to maximize lift for carrying heavy cargo. When empty, the aircraft weighs 128,000 kilograms, but at full capacity, it can reach 265,000 kilograms. It holds over 134,000 liters of fuel, and its 4 Pratt & Whitney PW2000 turbofan engines each produce more than 40,000 pounds of thrust, giving it the power to handle demanding missions worldwide. China's Xi'an Y-20 has made a massive impact on global military aviation, prompting countries like the US to take notice. What was once considered a newcomer has now positioned itself among top players in aircraft design, advancing both technology and performance. With developments like 3-dimensional printing, model-based engineering, and domestically built high-power engines, the Y-20 isn't just a cargo plane. It represents China's increasing reach and capability in modern military aviation. The F-35A is more than just a fighter jet. It's the perfect symbol of the United States' air dominance. Designed during a time when the United States demanded the highest level of air security, this aircraft redefined aerial combat with its unmatched capabilities. But does it live up to the hype? What sets the F-35A apart from every other jet in the sky? Join us as we reveal the capabilities of the most advanced hypersonic jet in the world. The F-35 emerged as a result of the Joint Strike Fighter program, which was born from the consolidation of various military aircraft development projects in the 1980s and 1990s. One of these programs, the Advanced Short Takeoff/Vertical Landing, ran from 1983 to 1994. Its goal was to create a replacement for the U.S. Marine Corps and the United Kingdom's Royal Navy's Harrier jump jet. As part of Advanced Short Takeoff/Vertical Landing, Lockheed Skunk Works developed a stealthy supersonic fighter, which incorporated the shaft-driven lift fan system for vertical lift. The concept involved a single-engine aircraft with a canard delta wing, weighing around 24,000 pounds. In 1993, Advanced Short Takeoff/Vertical Landing was renamed the Common Affordable Lightweight Fighter, and collaboration expanded to include Lockheed, McDonnell Douglas, and Boeing. The end of the Cold War in 1991 and the collapse of the Soviet Union led to significant cuts in defense spending, which impacted military programs. The U.S. Department of Defense restructuring led to the cancellation of several aircraft programs, including the U.S. Air Force's multi-role fighter and the U.S. Navy's Advanced Attack/Fighter projects. The MRF, designed to replace the F-16, was postponed due to the changing defense needs and a reduced role for the F-16. Meanwhile, the A/FX program, originally intended to replace the A-6, was modified after the cancellation of its predecessor, the A-12 Avenger II, in 1991. Following the review of defense priorities, both MRF and A/FX were canceled in 1993. However, insights from these programs contributed to the formation of the Joint Advanced Strike Technology Program, aimed at developing advanced warfare technologies rather than a new aircraft. In 1994, the Astoval-CAF and JAS programs merged, as the requirements for a concept demonstrator aircraft became evident. This led to the creation of the Joint Strike Fighter program in 1995, which sought to replace a variety of multi-role and strike fighters. International collaboration was a key element from the outset, with the United Kingdom becoming a founding member and contributing to the program. Other nations, including Italy, the Netherlands, and Canada, joined during the concept demonstration phase, with varying levels of involvement. By 1997, Boeing and Lockheed Martin were selected to develop concept demonstrators for the JSF, with their respective aircraft designated X-32 and X-35. Lockheed Martin's design built upon the technologies developed under the ASTOL program, including the innovative SDLF system, which allowed for short takeoffs and vertical landings. Unlike Boeing's X-32, which used a direct lift system, Lockheed's X-35 utilized a lift fan in the forward fuselage that could augment engine thrust for vertical flight. The X-35 was designed to accommodate three versions: a conventional takeoff and landing variant, a carrier-based version, and a short takeoff and vertical landing version. This commonality between the variants was a key feature of the design, with modifications made to suit each specific role, such as a larger wing for the carrier variant. The first flight of the X-35A took place on October 24, 2000, and was followed by a series of tests to assess its flight characteristics. After 28 flights, the aircraft was modified into the X-35B to demonstrate its STOVL capabilities, including hover and short takeoff and landing. The X-35C, which featured a larger wing for carrier landings, conducted its first flight on December 16, 2000. These successful tests demonstrated the capabilities of the JSF and set the stage for the next phase. In 2001, after extensive testing and evaluation, Lockheed Martin was chosen as the winner of the contract for the system development and demonstration phase of the JSF program. Additionally, Pratt & Whitney was awarded a contract to develop the F-135 engine for the F-35. The aircraft was given the F-35 designation, a surprise to many, including Lockheed Martin, which had expected the F-24 label. This marked the beginning of the F-35's development as a versatile, multi-role aircraft capable of meeting the needs of various military forces worldwide. The F-35 is a single-seat aircraft equipped with a powerful AESA radar positioned at the front. This radar can track and engage multiple targets simultaneously, both in the air and on the ground. A key feature of the aircraft is its distributed aperture system, which uses 6 infrared cameras mounted around the jet. These cameras create a 360-degree video feed that pilots can view on their visors, effectively giving them the ability to see through the aircraft and themselves during flight. Although primarily a missile warning system, it also serves as a backup for night vision, allowing pilots to see in complete darkness, including clouds, mountains, and other aircraft. Beneath the nose of the aircraft lies the electro-optical targeting system. This system uses infrared technology, similar to sniper or lightning pods, to identify and track ground and aerial targets. It provides precise coordinates to guide laser-guided bombs, enabling both planned and dynamic targeting of moving objects. The F-35 is often referred to as a supercomputer with wings because of its ability to dominate the battlefield. Designed to serve as a versatile platform, it can manage and share situational awareness across a 60-mile radius, coordinating with other aircraft and decision-makers to maintain battlefield control and enhance operational effectiveness. Stealth is a fundamental feature of the F-35, achieved through advanced design techniques and materials. The aircraft's radar cross-section is significantly reduced by the careful shaping of its airframe and the incorporation of radar-absorbent materials. Specific design choices, such as aligning edges, using continuous curves on surfaces, serrating skin panels, and concealing the engine face, contribute to reducing RCS. The F-35 also employs a diverter supersonic inlet, that utilizes a compression bump and forward-swept cowl, removing the need for a traditional splitter gap or bleed system. This innovation further decreases the radar signature by redirecting the boundary layer away from the inlet duct. The F-35's RCS is described as smaller than that of a metal golf ball at specific frequencies and angles, making it competitive with the F-22 in terms of stealth. The aircraft's design, which draws on lessons from earlier stealth models such as the F-22, features a durable radar-absorbent fiber mat skin that requires less maintenance than previous coatings. Furthermore, the F-35 has reduced infrared and visual signatures, along with stringent controls over radio frequency emissions to avoid detection. Much of the work involves the radar system, which identifies targets and shares that information with others. A significant part of the aircraft's capabilities is found in its outer panels. Beneath these panels are advanced supercomputers and large sensors integrated into nearly every section of the plane's exterior. These technologies are complex, and even experienced operators may not fully understand all the systems. The aircraft's stealth is especially effective against high-frequency X-band radar, though it is vulnerable to low-frequency radars, which can detect stealth aircraft through Rayleigh scattering. However, low-frequency radars are less precise, more prone to interference, and generally more conspicuous. To further conceal its radar cross-section, the F-35 can also use Lundberg lens reflectors to obscure its signature. Moving on to the inside of the aircraft, the cockpit of the F-35 is designed to enhance situational awareness with a 20 by 8-inch panoramic touchscreen that displays vital flight and combat information, including flight instruments, store management, and caution warnings. This screen can be customized to the pilot's preference, with a smaller standby display positioned below it. A speech recognition system aids communication, and the aircraft does not use a traditional head-up display. Instead, all relevant data is shown directly on the pilot's helmet visor via a helmet-mounted display system, allowing the pilot to access information regardless of head position. The canopy is a single tinted piece hinged at the front for structural integrity, while the Martin Baker US-16E ejection seat is equipped with a twin catapult system. The aircraft uses a hands-on throttle and stick system and an onboard oxygen generation system powered by the integrated power package ensures life support with emergency backup systems in place. One feature people often find fascinating in fighter jets is their weaponry. The F-35A variant is unique as it includes an internal cannon located near the left air intake of the jet. This cannon can hold 181 rounds of 25mm ammunition. Although this is larger than the ammunition carried by most fourth-generation fighter jets, it is still smaller compared to what an A-10 uses. A valuable feature of this cannon is its burst-around limiter, allowing the pilot to control how many rounds are fired with each trigger pull. For instance, a pilot can choose to fire only 20 rounds at a time, ensuring better ammunition management. This setup allows for multiple precise shots during a mission. Beneath the jet, the bomb bay doors open to reveal its primary weapons storage area. Inside the bomb bay, the F-35 can carry bombs of varying sizes, ranging from 250 pounds to 2,000 pounds, depending on the mission's needs. For example, when targeting heavily fortified structures like bunkers or tanks, the 2,000-pound bomb might be used. Alternatively, for missions requiring precision against multiple targets, smaller bombs can be deployed to hit up to 8 separate locations within a 70-mile range. This flexibility makes the jet highly versatile and practical in diverse scenarios. The aircraft also features one of the most advanced flight control systems globally, comparable to that of the F-22 Raptor. Known as a fly-by-wire system, it is more sophisticated than the system used in the F-16 Viper. Essentially, this system interprets every movement of the pilot's controls, such as the stick and throttle, as a digital request, ensuring precise and efficient responses. When comparing the F-22 Raptor and the F-35, both being fifth-generation fighters, there are notable differences. The F-22 features twin engines, offering extraordinary maneuverability and superior thrust vectoring capabilities, making it ideal for air combat. Its larger airframe enhances its role as a dominant dogfighter. On the other hand, the F-35, a newer design by approximately a decade, is smaller and optimized for versatility. While it remains agile, it can carry larger payloads, including 2,000-pound bombs, compared to the F-22 1,000-pound capacity. Additionally, the F-35 is equipped to hold more air-to-air missiles internally, emphasizing its multifunctional air-to-ground and air-to-air capabilities. The F-35 Pratt & Whitney F-135 engine is among the most potent fighter jet engines ever created, producing an impressive 43,000 pounds of thrust in afterburner mode. This incredible power supports the entire demonstration, lasting about 13 minutes, and ensures reliable performance without concerns of engine failure during high-stress operations. Remarkably, the engine's thrust exceeds the aircraft's weight, enabling astonishing maneuvers, including spins and rapid direction changes. By about 2 minutes into a demonstration, the thrust-to-weight ratio allows for unparalleled agility, showcasing the F-35 engineering excellence. From that moment onward, the acceleration increases rapidly to the point where it becomes challenging to manage, especially at sea level or during a demonstration over a beach. For those unfamiliar, there are 3 distinct variants of the F-35, the A, B, and C models. The A model is the conventional version primarily used by the Air Force. It is designed for standard takeoff and landing, just like any typical airplane. The B model, used by the Marine Corps, is a short takeoff and vertical landing variant capable of hovering. Lastly, the C model is intended for carrier operations. It is launched via a catapult from aircraft carriers and lands using an arresting cable. It is fascinating to consider the experience of flying such an advanced machine. When piloting the F-35, and especially when another F-35 approaches alongside, one can't help but marvel at the aircraft's incredible design. One interesting fact is that at Hill Air Force Base, in the Aircrew Flight Equipment section of the 388th Operational Support Squadron, there is a special area dedicated to fighter pilot preparation, similar to a locker room for athletes. Just as sports teams gear up before an important game, F-35 pilots have a designated space to prepare themselves for flight. This area is where they store essential gear, such as G-suits, survival vests, and most notably their helmets. One of the key components of the F-35 cockpit system is the Vision System's International Helmet-Mounted Display. This system eliminates the need for a conventional head-up display by projecting all relevant data onto the pilot's helmet visor. Additionally, it provides night vision and infrared imagery through the distributed aperture system, enabling the pilot to effectively see through the aircraft. The system allows the pilot to target and fire missiles even when the aircraft is not directly aimed at the target, thanks to off-bore sight missile seeker cues. Each helmet costs around $400,000, and while the system offers significant advantages, concerns have been raised about the potential risk to lightweight pilots during ejection due to the added weight of the helmet. Development of the HMDS encountered issues with vibration, sensor displays, and night vision during the testing phase, leading to the consideration of an alternative system based on the AN/ABS-9 night vision goggles. However, after further improvements to the baseline HMDS, the development of this backup system was halted by 2013. By 2016, a new Gen 3 helmet was introduced, offering enhancements like improved night vision, better display systems, and automated alignment, marking a significant milestone in the F-35 cockpit development. These helmets are remarkable, being the most advanced fighter pilot helmets ever created. They are integrated directly into the aircraft, replacing the traditional heads-up display found in older jets. Instead, all necessary flight data, including airspeed, altitude, heading, warning systems, and targeting information, is projected directly onto the helmet visor. In addition to the helmet, pilots also wear specialized gear to support them during flight. Below the neck, pilots are equipped with a G-suit designed to counteract the forces experienced during flight, ensuring blood circulation to vital areas to prevent loss of consciousness. Pilots also wear survival jackets, which contain essential equipment such as flares, flashlights, tourniquets, and GPS systems, all of which are vital if the pilot ever needs to eject from the aircraft. Finally, the oxygen mask connects directly to the aircraft to supply the necessary oxygen during flight, ensuring the pilot's safety and ability to function effectively. Comparing the F-35 with the Chinese J-20, these air fighters are 2 cutting-edge fighter jets, each boasting impressive strengths. The F-35 stands out for its superior stealth and widespread adoption among United States allies. At the same time, the J-20 is known for its speed and ability to target critical support aircraft, making it a serious contender. Despite the J-20's advantages, including supercruise capability and heavy investment in development, it lacks a cannon, and its pilots have limited combat experience. In a potential conflict over Taiwan, the F-35's stealth and the battle-tested expertise of U.S. pilots could give it an upper hand, though the J-20 remains a formidable opponent. The J-20, nicknamed the Mighty Dragon, officially joined China's Air Force in 2018, with around 150 currently in service. Its design closely resembles features of the F-35 and F-22, sparking speculation that China used cyber espionage to copy U.S. technology. Like the F-35 program, the J-20 has seen massive financial investment, costing an estimated $4.4 billion, with each jet priced at $120 million. With both nations mass-producing these fighters, a future clash over hotspots like Taiwan or the South China Sea seems possible. The question remains, which jet would reign supreme in this battle for air superiority? The J-20 is a powerful twin-engine fighter jet used by China. It currently flies with Russian-made AL-31 or Chinese WS-10C engines, but China is working to upgrade it with next-generation WS-15 engines for greater power and performance. However, progress on replacing the engines has been slower than expected. Despite this, the J-20 boasts impressive capabilities that make it a key player in modern air combat. With a top speed of Mach 2, a range of 1,100 nautical miles, and a ceiling of 66,000 feet, the J-20 is both fast and capable of covering long distances. It can carry a significant amount of fuel and is equipped to launch a variety of missiles, including air-to-surface and anti-ship types. This versatility allows the J-20 to excel in both ground attack missions and air superiority roles, enhanced by its thrust vectoring control and strong thrust-to-weight ratio. However, the J-20's stealth capabilities fall short when compared to the American F-35. The forward canards on the J-20 increase its radar visibility, giving the F-35 an advantage in spotting and engaging it first. Despite this, Chinese strategists believe the J-20 can still punch through contested airspace to target critical American support aircraft like tankers and reconnaissance planes. The newer J-20 models also include supercruise technology, allowing them to sustain high speeds without afterburners. This gives them an edge in speed over the F-35, which maxes out at Mach 1.6. The J-20's performance has drawn the attention of United States military leaders. Earlier this year, F-35s and J-20s came into proximity during an encounter over the East China Sea. General Kenneth Wilsbach, commander of the U.S. Pacific Air Forces, described the J-20's command and control systems as impressive, signaling that China's advanced fighter jet is not to be underestimated. NASA has been on the precipice of creating one of the most disturbing aircraft that the world has ever seen for a long time. However, it has often slipped right through their fingers every time they get close enough. But the emergence of Donald Trump in January 2025, as the new president of the United States, seems to have sped up those plans, with his decision in March to let Boeing build a sixth-generation fighter jet called the F-47. Could this create a global arms race? How will China and Russia respond? Join us as we discuss the potential unveiling of the F-47 in the United States. Many years ago, battles were fought and won mostly on the land, with soldiers learning to handle hand-to-hand combat and how to navigate rugged terrains. However, as time went on, aerial dominance emerged and has since become a staple in warfare, with top nations vying to create the best aerial offense and defense. Among these top nations are China, Russia, and the United States, each boasting strong technological intelligence and having dished out some of the greatest weapons over the years. However, aerial dominance requires more than technological know-how, as there is a need for grit and willingness to push the envelope, no matter how many times they fail. As an example, World War I mostly ushered in the age of aerial warfare, as it moved on from strategic ground battles, launching hand grenades or bigger explosives from the trenches, to witnessing dogfights between biplanes, with hopes that the best man wins. However, at the time, it was more brawn than brains. It was a dogfight with not enough strategy behind it. But the early 20th century has now prioritized aerial dominance, especially with renowned war specialists, including generals who have actually seen combat, declaring that whoever controls the sky has everyone else at their mercy, ushering in the greatest global arms race that the world had ever seen. The United States remains at the top of the food chain with its fifth-generation fighter jets, increasing their aerial superiority beyond control, staying nearly out of reach for other nations. While countries like China and Russia have contributed to aerial combat technology with fighter jets like the Sukhoi Su-57, Sukhoi Su-35, Sukhoi Su-30, Mikoyan MiG-35, Mikoyan MiG-31, Chengdu J-20, Chengdu J-10, Shenyang J-11, Shenyang J-15, and the Shenyang J-16, competing with the very best of what the United States has to offer. The United States, as of March 2025, has finally decided to create an aerial phenomenon that pulls them clear of anything that the nations might have to offer. Although the idea had been in existence for many decades, it has often been regarded as a bit of an imaginary thought that defies the real capabilities of science. However, the United States, with its reputation for having weapon-building companies that have helped them defy the odds in a lot of wars, has decided to take on the project. The F-47 is a project that is poised to replace the Lockheed Martin and Boeing F-22 Raptors, one of the United States' most important fighter jets. The F-22 Raptor is a twin-engine, jet-powered, all-weather, supersonic stealth fighter aircraft. As a product of the United States Air Force's Advanced Tactical Fighter, or ATF program, it was designed as a fifth-generation air dominance fighter jet. However, the vision for the F-47 is to be a game-changing maverick that could turn the tide of a war on its own without the support of another aircraft, like some that need a loyal wingman to scout ahead before they are deployed in full effect. Since the plans of the F-47 came to life, the United States has sounded out the top weapon-producing companies like Lockheed Martin, Boeing, and Raytheon Technology, or RTX, looking for the perfect company to flesh out the latest requirement of the United States Air Force. After a long deliberation, the President of the United States decided on Boeing, awarding them the contract to build the powerful F-47, which he described as a fighter jet that will have an unprecedented power. Although most of the details of the F-47 remain confidential, the President of the United States gave away a bit of information on what to expect. The Next Generation Air Dominance, or NGAD, program initiative is planning to build the F-47 in such a way that it is virtually unseeable and undetectable by any type of A-2AD aerial defense system that is employed by most of the top countries around the world. The initiative of the Next Generation Air Dominance created by the United States Air Force, or USAF, is centered around the vision to create a family of systems that can take on the responsibility of long-range strikes as a killer fighter jet and also have the ability to function as a hunter fighter jet. However, it was definitely easier said than done. Since the initiation of the program, the United States Air Force has found it difficult to build a prototype that suits the plan to perfection until 2014, when the Defense Advanced Research Projects Agency, or DARPA, launched the Aerospace Innovation Initiative to build X-plane prototypes for developing and maturing next-generation fighter aircraft technologies. These prototypes, created by the Defense Advanced Research Projects Agency, served as full-scale flight prototypes for Boeing, which was, at the time, in need of a demonstrator for creating the Penetrating Counter-Air Vehicle, a terminology also used in describing the F-47. Following their demonstration with the X-planes, Boeing succinctly hoped to develop a penetrating counter-air fighter jet that could operate without an uncrewed collaborative combat aircraft, otherwise called a CCA. However, the advancement of technology over the years has created a new conundrum for Boeing, who had once considered having a solo fighter jet for future missions. Leaders in the United States Air Force suddenly had new demands, asking for unmanned drones that could accompany the manned fighter jets on missions. By March 2023, Air Force Secretary Frank Kendall had a clear idea of what the United States entity said the service was planning: for a notional fleet of about 200 next-generation air dominance fighters and 1,000 advanced drones to carry additional munitions or perform supporting missions. As expected, a country like the United States naturally has aerial battles in highly contested airspaces, hence the need for complete dominance. However, with the economic ties into making one F-47 fighter jet, Questions have lingered on just how much the United States Air Force needs to go along with the project, especially with the F-35 Lightning II and the F-22 Raptor remaining as potent as they have always been, with very recent obvious demonstrations in the Russo-Ukrainian War. While the imagination and reason behind the program might be right, getting past Congress proved really tricky, with heavy analysis required on the appropriation of taxpayers' funds. However, in early March 2025, United States Air Force leaders stepped out to debunk the idea of canceling the project, making remarkable assertions about the importance of the project over anything else. According to Major General Joseph Kunkel, Director of Air Force Design, Integration, and Wargaming, the United States Air Force has studied what the reason behind the need for the production of the F-47 is. We tried a whole bunch of different options, and there was no more viable option than the Next Generation Air Dominance Initiative to achieve air superiority in this highly contested environment, he said. While his reasons were valid, they were still measured against the dominance of the top country's ability in the air, with nations like China, Russia, and even the demilitarized Japan in the contest to help justify the reason for the hefty investments required for building the F-47 project. For some perspective into the required numbers needed to create an F-47, each one is primed to cost at least 3 times the price of the tried and trusted Lockheed Martin F-35 Lightning II, each of which costs about $100 million. After getting a consistent look at the numbers and contrasting the level of the United States aerial defense and offense with other top countries, using data from the National Aeronautics Space Administration, or NASA, as a guide to make a decision, the data already suggested that the United States would need to make some serious improvements to their air fleets. But China's 6th-generation aircraft program was the real spark that initiated the approval of the Council. The awarded contract to Boeing to manufacture the F-47s is estimated to be around $20 billion, over double the budget that was passed along for former aircraft projects. But what makes the United States so interested in the aerially dominant Chinese 6th-generation aircraft project? The 6th-generation aircraft projects in China are created as the perfect design for futuristic use, with 2030 set as the possible date for a flight test. But why do the Chinese decide on a 6th-generation jet? Aerial dominance has always been allocated to one nation as the alpha, the United States, especially with the creation of air beasts like the F-35 Lightning II and the F-22 Raptor series. While they have been models for top countries like Beijing and the Kremlin to build their aircraft on, they have also been impediments to their decision to take over countries in the Indo-Pacific regions and parts of Southeast Asia. For some context, the Kremlin has been in pursuit of the most powerful one of the biggest territories by landmass in the world, Ukraine, with rigid claims that these parts used to belong to the old Russia when the USSR was still a tangible concept, before they were disbanded on December 26, 1991. Hence, they had been attempting a takeover since the 90s. However, owing to the stubborn will of the Ukrainians, they had repelled the advances of Russia for a long time. But in that period, Russia was still licking their wounds from the Second World War. Ergo, a conquest was impossible at the time. Fast forward to 2014, the Kremlin decided on invading Ukraine, forcing them into submission and trying to take Crimea from them through annexation. While Ukraine had been annexed for 11 years, Russia had decided against taking Ukraine on. Although in an all-out war with Ukraine, Russia stood a higher chance against Ukraine owing to its vast military might in foot soldiers, weapons, ammunition, and more importantly, its aerial power. With access to aerial monsters like the Sukhoi Su-57, Sukhoi Su-35, Sukhoi Su-30, Mikoyan MiG-35, and Mikoyan MiG-31. However, they tried to create a political atmosphere where they could resolve it with negotiations, hoping that they would be granted access into Ukraine as a Kremlin-controlled sovereign state. Since Ukraine chose its sovereignty over a negotiated peace that allowed Russia control of their sovereignty, the Kremlin decided to invade Ukraine in 2022, leading to an all-out war that has, so far, claimed thousands of lives on both sides. However, Ukraine remained resilient, resisting the Russian approach with their wit and bravery from soldiers who were willing to sacrifice their lives, regardless of how asymmetric the war was. While Russia had been expected by the entirety of the world to simply crush Ukraine in one blow, the West interfered, with the United States at the forefront, leading the charge by sending war efforts to Ukraine. While the financial reload was a problem for Russia, the Kremlin's biggest gripe came with the United States' willingness to send aerial support like the F-16s. However, as the war wears on for much longer, Ukraine seems unnaturally able to hold out, as they anticipate a possible addition of some of the crown jewels of the United States Air Force fleet, including the F-22 Raptors and the F-35 Lightning II, both of which the Kremlin rarely has an answer to. Rumors from the Russo-Ukrainian war pipeline have been surrounded with a possible agreement for a sit-down with the United States, which would be in charge of bringing up peace talks, and how much the outcome could influence the United States' desire to unleash their aerial beasts. While Russia already struggles to contain the fifth-generation aerial Mavericks that the United States could potentially send as war aid to the Ukrainian side of the war, imagine a sixth-generation jet which is virtually undetectable by present-day radar technology. It was the perfect leash from the United States, keeping the Russo-Ukrainian war from escalating beyond the wild margins it already borders on. Furthermore, the same could be said for China, which has been in the southeastern waters of Asia, with a decision to expand into Taiwan, taking over their sovereignty and bending them to the will of the Chinese government, making them a simple extension of Beijing. However, once again, the United States has butted in, stopping them dead in their tracks, using the government-recognized ploy of an act called the Taiwan Relations Act, or TRA, enacted on April 10, 1979. While the United States does not recognize the terminology of Republic of China, they allow the use of the term governing authorities on Taiwan. But more importantly, the act provided the United States with the rights to engage in arms sales and even joint training of their most elite task forces with Taiwan's. Although the act does not make any provisions for directly interfering in a battle that helps them keep their sovereignty, the provision for arms sales and giving aid in finance and military-grade weapons has served as a key in keeping China at bay, basically stopping them from going up against the United States, which has a much stronger Navy and Air Force, making any war between them largely asymmetrical. Aside from the act, the United States has displayed a show of force using unconventional means to fluster Beijing into a potential surrender before their war on sovereignty even begins. For some context, the United States Naval Forces has deliberately patrolled the deep Pacific waters along the Taiwan Strait using some of their most feared aircraft carriers, like the USS Ronald Reagan, which is a Nimitz-class carrier, the USS Carl Vinson, and the USS Nimitz, all of which are capable of taking the massive responsibilities of boarding huge aircraft like the F-18 Super Hornets and the E-2D Hawkeye, and also flexing the Maverick of the United States Air Force, the F-35 Lightning II, forcing China into a rethink of their strategy to take on Taiwan. However, in a bid to improve their aerial dominance and seeking ways to win the battle for aerial dominance against the West, especially the United States, which has stopped them from the conquests of smaller countries like Taiwan, they created a sixth-generation aircraft project that drastically improves their Chengdu J-20 aircraft, which the United States seems to have an answer for. While Russia and China remain in the arms race to wrest control of the air beast created by the United States, only China seems to really have made any headway, keeping the United States on its toes. After successfully developing the fifth-generation J-20 stealth fighter, China was then working on the development of a next-generation aircraft. In January 2019, Dr. Wang Haifeng, chief designer of the Chengdu Aircraft Corporation, or CAC, announced that China had begun pre-research on sixth-generation aircraft, predicting that the program would come to fruition by 2035. However, the United States, with the support of President Donald Trump, has been forcing a much closer return, hoping to get their first prototype available 5 years earlier than the People's Republic of China. But with the United States plan still going through a rigorous bureaucratic process, China, on 5 August 2025, a third tailless stealth aircraft prototype was spotted in China, with a distinct silhouette different from the previous J-36 and J-50. The photo on social media displayed an aircraft with a pointed nose, highly swept wings with cropped tips, and a W-shaped trailing edge featuring a central extension in a triangular shape. Defense analysts speculated the airframe was an early prototype of China's sixth-generation Loyal Wingman drone or a crewed aircraft competing with its already made J-36 and J-50. The pair was the perfect representation of the hunter-killer mission fighter jets. While the photos spread across China and beyond, Beijing has refused to comment, silently obeying the United States laws on the restriction of their forceful expansion into Taiwan. But could that change soon? While the Chinese reflected supremacy in its flagship sixth-generation fighter, there are claims from sources inside the Department of Defense that tell a story of the United States being further along the production line of the F-47s than what has been said in the media, hoping to use its element of surprise to catch other countries, especially China, off their guard. The same source claims that the United States has created a joint operation between Boeing, which is in charge of the military designs, and the aerospace eggheads in the National Aeronautics and Space Administration. Aside from being a hunter-killer capable fighter jet, the F-47 is supposed to be capable of unprecedented speed, in this case, supersonic speed. The source claims that the National Aeronautics and Space Administration has been discreetly helping Boeing to test the supersonic capabilities of the engines that will be fitted into the F-47 before its release. The supersonic capable engine is suggestive of an aircraft being able to fly between the speeds of Mach 1 and Mach 3, meaning that it could travel 3 times faster than the speed of sound. The test has been rumored to be carried out because Boeing intends to fit the engine into an unprecedented structural design that could withstand the heat that comes from the friction with the air when the aircraft travels at such speed. Whether the United States upstages China in their release of the sixth-generation aerial beast or Beijing wins this global arms race, only time will tell. America's skies are about to change forever with the revolutionary Boeing F-47, our latest stealth fighter. Combining cutting-edge design with unmatched speed and agility, this aircraft redefines modern warfare. In this video, we'll dive into the secrets of its stealth technology, innovative engineering, and the game-changing impact it promises for America's defense. Buckle up and join us as we explore America's new stealth fighter, the Boeing F-47. On Friday, March 21, 2025, a groundbreaking announcement was made in the Oval Office that will forever alter the landscape of U.S. air power. President Donald Trump, alongside Secretary of Defense Pete Hegseth and Air Force Chief of Staff General David Alvin, personally declared Boeing the winner of the Next Generation Air Dominance NGAD fighter initiative. This historic moment, delivered in one of America's most iconic settings, underscored the nation's commitment to advancing its tactical air capabilities and set the stage for a bold leap into the future of aerial combat. President Trump revealed that an experimental version of the F-47 has been secretly soaring through the skies for nearly 5 years. According to him, this aircraft is far beyond anything any other nation has ever built. There's no competition, he declared. I've seen every other jet out there, and nothing even comes close. This isn't just an upgrade, it's a whole new level. You know, level 5 is good, he said, but this is level 6. The F-47 is armed with cutting-edge stealth technology, making it virtually invisible to enemy detection. It possesses unparalleled power, setting a new benchmark for fighter jets. It's the most powerful aircraft of its kind ever created, Trump stated. And its maneuverability? Unmatched, nothing like it has ever existed before. Speed is another jaw-dropping feature. It's faster than anything people are used to. Over Mach 2, he added. That's something you don't hear very often. Beyond its speed and power, the true purpose of the F-47 is to maintain America's dominance in the skies. According to Trump, America's enemies will never see it coming. And if the aircraft is ever needed in combat, adversaries will have no chance to react. However, he expressed hope that it would never have to be used for such purposes. A new fleet of these groundbreaking jets is set to be built and deployed under his administration within the next few years. He assured that production is already well underway, with factories and facilities prepared. His vision is to ensure that the United States continues to lead the world in air superiority. At the core of this monumental development is Boeing's revolutionary sixth-generation stealth fighter, now designated the F-47. This aircraft is far more than just an upgraded jet. It represents a complete transformation in the way air combat will be conducted. With its state-of-the-art stealth features, incredible speed, and unmatched maneuverability, the F-47 is engineered to counter emerging threats and redefine the very nature of modern warfare. The U.S. Air Force plans to begin fielding this game-changing fighter within the next decade, highlighting an urgent need to maintain technological superiority in an increasingly unpredictable world. The NGAD initiative is designed to develop a next-generation fighter platform that can operate with other advanced systems. Born from the need to outpace global threats, the program integrates innovative technologies into an adaptable combat jet. Previously shrouded in uncertainty over costs and strategic relevance, the renewed commitment from this announcement has breathed new life into the initiative, paving the way for a future where American air power leads global defense. While the announcement itself is a major milestone, it is equally important to consider the long and storied competition that has brought us to this point. The race to create the ultimate fighter jet has long been a contest between two of America's most storied defense contractors, Boeing and Lockheed Martin. Lockheed Martin, with its celebrated F-22 Raptor and F-35 Lightning II, has been a dominant force in military aviation for decades. Their designs have set high standards in stealth, agility, and technological innovation, becoming symbols of American prowess in the skies. However, this rivalry is steeped in a rich historical context that dates back to the Cold War era. During those tense years, the need for air superiority drove both companies to push the limits of engineering and design. Every new aircraft was a critical piece in the puzzle of national security, and competition was fierce as both firms sought to secure America's strategic interests. The innovations born from this rivalry led to rapid advancements in technology, from cutting-edge stealth materials to sophisticated flight control systems, all of which have shaped the modern fighter jets we see today. Despite Lockheed Martin's illustrious history and its impressive portfolio of advanced aircraft, Boeing's recent triumph in the NGAD fighter initiative signals a potential shift in the balance of power within the defense industry. Boeing's approach with the F-47 leverages decades of aviation experience and a fresh perspective on the challenges of modern warfare. Their success is a testament to the company's relentless drive to innovate and redefine what is possible in military aviation. This victory is not merely about winning a contract. It represents a bold statement that Boeing is ready to lead the next generation of fighter jets into an era where agility, stealth, and speed are paramount. On the day the F-47 was announced, the world of military aviation was buzzing with excitement and curiosity about what this new stealth fighter would look like. Although we have only 2 image renders from the Air Force, they already tell us a lot about this mysterious aircraft. One image shows a plane with a very distinct chine starting right from the nose, a sharp, angular line that gives the jet an aggressive, futuristic look. The other image is more artistic, with much of the aircraft hidden in swirling clouds and vapor, adding an air of mystery to its design. One of the more striking details in the clear render is the suggestion of canards. These small, wing-like structures, which appear to have a high dihedral angle, could help improve the plane's maneuverability and overall stealth. The fact that the other render doesn't show these canards might be due to artistic license or simply a different angle that hides certain features. However, both images agree on one unusual characteristic. The wings seem to share the same high dihedral angle. This design choice is not common among fighters and is likely a deliberate measure to enhance stealth capabilities. Many modern jets like the F-22 and F-35, and even some Chinese fighters like the J-20 and J-36, have a radar signal trap when the wing meets the lower fuselage. In contrast, the F-47 appears to avoid this pitfall by presenting a single diamond-like cross-section when viewed from below or the sides. This streamlined design could be a game-changer, offering a significant advantage in evading radar detection. When we compare this new fighter to other iconic aircraft, a few interesting points come to light. For instance, Boeing's bird of prey demonstrator from the 1990s comes to mind. That small, experimental plane was famed for its incredibly low radar cross-section. In fact, it was so stealthy that while you could see it with the naked eye, fighter jet radar couldn't track it even from a few miles away. Its radar cross-section was rumored to be around -70 decibels, which is an impressive achievement, especially when you consider that the F-22's is about -40 decibels. Imagine that. The technology behind the bird of prey was already groundbreaking 30 years ago, and now we see echoes of that innovation in the F-47's design. The renders leave some mysteries too, as the rear half of the F-47 is not visible. This means we can only speculate about the design of its tail section, engines, and other key features that lie out of view. However, two more details stand out. First, the canopy appears fairly wide compared to the rest of the plane. A wide canopy could be an indication of enhanced pilot visibility and perhaps a more spacious cockpit, which might be designed for advanced avionics or even a dual-crew configuration in future variants. Second, the front landing gear is notably different. It has a single wheel rather than a twin-wheel setup, which is often seen in larger, heavier aircraft like the Chinese J-36 fighter. This detail suggests that the F-47 is not meant to be a massive behemoth with a 50-foot wingspan and weighing 70 tons. Instead, it likely falls in the size range of the F-22 or even a bit smaller, which would make it more agile and responsive in combat. This size and design philosophy could be a key factor in its operational role. A fighter jet that is not overly large can take advantage of increased speed, agility, and potentially lower maintenance costs, all while maintaining a strong stealth profile. In today's fast-changing combat environment, these factors are crucial. The ability to evade enemy radar and respond quickly to threats is at the heart of modern air combat. With the F-47, it seems Boeing is banking on a design that merges the best elements of past innovations with fresh, modern engineering. It's interesting to see how these features compare to those of other advanced fighters. The F-22 and F-35 have long been the benchmarks for stealth and agility in U.S. military aviation. Their designs have been refined over years of development and combat experience. On the other side of the globe, China's J-20 and the lesser-known J-36 have pushed the envelope in their own right, though they sometimes fall prey to design challenges like the radar signal trap mentioned earlier. The F-47, with its unique diamond-like cross-section and potential design refinements such as the canards and wing dihedral, seems poised to take lessons from these aircraft and perhaps even improve upon them. The subtle nod to Boeing's own heritage with the bird of prey is also a reminder of how far technology has come. The lessons learned from experimental aircraft decades ago continue to influence modern designs. It's like watching history repeat itself, only with a futuristic twist. It's easy to get excited about the possibilities of a new fighter jet, and the F-47 is no exception. At first glance, some details seem almost contradictory. For instance, the wide cockpit might make you wonder if the design features side-by-side seating. But then, if that were the case, why would the F-47 have a single-wheel front landing gear? Chances are that seating arrangement isn't in play. This simple observation tells us a lot about the design philosophy behind this new fighter. For many years, the Air Force talked about needing a large and heavy sixth-generation fighter. That was the path taken by China with its J-36, a design built on the idea that a bigger plane would offer more power and range. However, over the past year, hints have emerged suggesting that a smaller F-35 size fighter might be just as effective. The F-47 renders seem to back up this new approach. The fact that the F-47 might be more compact suggests that the Air Force is rethinking its priorities, focusing on agility and efficiency rather than sheer size. General Alvin, the Air Force Chief of Staff, released a statement loaded with praise for the F-47, calling it the most advanced, lethal, and adaptable fighter ever. He added that it is designed to outpace, outmatch, and outmaneuver any adversary. When you hear words like these, it really sets your mind racing with possibilities. Yet some of the phrasing raises interesting questions. Outmaneuver is not a word typically associated with next-generation fighters, which often sacrifice traditional turning ability in favor of stealth and speed. Instead, it might be more accurate to say the F-47 is built for agility. Its ability to rapidly change location and altitude in a split second could be the real game changer. How might this agility be achieved? One possibility is through advanced engines that offer the best of both worlds. Imagine an engine that can operate in turbofan mode for fuel efficiency during long patrols and then switch to turbojet mode when a burst of power is needed for quick maneuvers. This kind of dual-mode operation could give the F-47 an edge over current fighters by allowing it to conserve fuel without compromising on performance during critical moments. Another eyebrow-raising claim from General Alvin is about the fighter's range. He stated that the F-47 will have a significantly longer range than today's fifth-generation fighters. Currently, the F-35 boasts a combat radius of nearly 900 miles for air-to-air missions. How can a fighter that is presumably similar in size or even smaller manage to exceed that range? The answer might lie in engine efficiency. Advanced engines now in development are promising at least a 25% improvement in fuel efficiency over existing models. In addition, the F-35 is built as a multi-role aircraft, designed to carry heavy loads and endure long service lives of up to 40 years. In contrast, the F-47's airframe might be engineered for a shorter lifespan, designed to be replaced or upgraded much more frequently. This approach could allow for rapid technological refreshes, ensuring that the fighter always benefits from the latest innovations. It's fascinating to think about how these design choices reflect a shift in strategy. The Air Force once believed that a larger, more robust fighter was necessary to dominate the skies. But as technology advances, the emphasis seems to be moving toward nimbleness and efficiency. The F-47 might well be a symbol of this new approach. A fighter that is smaller but faster, with advanced engines that let it cover more ground, could change the way air combat is conducted in the future. By rethinking traditional design elements, the F-47 seems to blend lessons from past successes with bold new ideas. The possibility of a wide cockpit might initially hint at side-by-side seating, but the single-wheel front landing gear strongly suggests a different layout. This detail hints at a careful balance between pilot comfort and overall aircraft performance. A wide canopy might still allow for excellent visibility and situational awareness, even if the seating arrangement is more traditional. Such design decisions are likely driven by the need to keep the fighter's size manageable, thereby enhancing its agility. At the same time, this new fighter is positioned against a backdrop of evolving strategic thinking. The earlier vision of a bulky sixth-generation fighter, exemplified by China's J-36, is now being reconsidered in favor of a design more in line with the F-35. This shift reflects a broader trend in military aviation, where the focus is on creating platforms that can be updated more frequently, rather than relying on a single design to carry the burden of air dominance for decades. General Alvin's comments also suggest that the F-47 will be a multifaceted platform. By emphasizing the ability to outpace, outmatch, and outmaneuver, he paints a picture of a fighter that is not only fast but also versatile. The emphasis on rapid changes in location and altitude could indicate a design optimized for dynamic combat environments, where quick decisions and faster responses are critical. The F-47 is not only a leap forward in stealth technology, but also a smart, cost-effective design that promises to change the way we think about fighter jets. One interesting detail is that the F-47 may be built to carry only a few AMR/AAM-sized air-to-air missiles. This might seem like a limitation at first, but there's a clever twist. The Air Force has hinted that each F-47 will fly with more than 5 drones. These drones would serve as the primary missile carriers and shooters. In other words, the fighter jet itself wouldn't need to store a large arsenal of weapons. With the drones doing the heavy lifting in combat, the F-47 can remain lean and agile, reducing its overall weight and enhancing its stealth capabilities. Another interesting aspect is the use of novel construction methods, like metal printing, in building the F-47. This modern manufacturing process, along with other design optimizations, may allow engineers to create extra space for fuel while keeping the plane lighter. The result? A significant boost in range. Early estimates suggest that the F-47 could offer a 25% to even a 50% increase in range compared to today's F-35. Imagine the strategic advantage of a fighter jet that can fly farther, engage the enemy for longer, and still return home safely without refueling too often. Furthermore, there's talk that the F-47 may be designed with just one engine. Fewer engines mean less weight, which could further enhance its range and agility while also simplifying maintenance. General Alvin has been very positive about the F-47's progress. He mentioned that multiple experimental demonstrators have already flown over the past 5 years. According to him, the F-47 has reached what he called unprecedented maturity. This statement speaks volumes about how much testing and refinement have already gone into the project. It's not just a concept on paper. It's a real, tangible machine that has been proven in flight tests. In fact, General Alvin revealed that a prototype will take to the skies during President Trump's term, by 2028 at the latest. This timeline is remarkable because it is faster than the development timelines for previous fighter jets like the F-35 or the F-22. However, it is important to note that while the prototype may fly soon, additional years will be needed for thorough testing and refinements. The first serial-produced airframes might not join the Air Force inventory until around 2032, with initial operational capability expected to kick in around 2035. One of the most promising aspects of the F-47 is its cost-effectiveness. The Air Force has quoted the F-47 as being cheaper than the F-22. This lower cost is not just about saving money, it means that the service can afford to buy more of these aircraft. With a larger fleet, the overall program cost is spread out over more jets, lowering the price per unit even further. This approach is similar to why the F-35 is currently cheaper than the F-15EX. In previous years, before a smaller scale option was considered, programs like ANGAD were described as costing hundreds of millions per jet, with only around 200 units being affordable. The move toward a smaller, more cost-effective fighter like the F-47 shows a significant shift in strategy. It suggests that the future of air combat may not require massive, heavily armed air cruisers, but rather more nimble and advanced aircraft that can work in tandem with drone formations and tanker aircraft. This design philosophy indicates that the F-47 is intended to be a manageable aircraft, likely somewhere between the size of the F-35 and the F-22. Despite its relatively smaller size, the F-47 is set to be much more advanced. Its design, combining reduced weight, enhanced fuel capacity, and advanced stealth, makes it a very appealing option for the future of U.S. air power. The ability to launch alongside a swarm of drones means that this fighter jet can be a force multiplier on the battlefield. In modern warfare, where agility and technological integration are key, having a fleet of these smaller, smarter fighters could prove to be a game changer. It's also worth noting that this shift toward a more compact and efficient fighter was not a last-minute decision. The U.S. has been preparing for this transition for quite some time, possibly even before the alleged pause in the NGAD program during the summer of 2024. In fact, Boeing had already been constructing new facilities in anticipation of these future needs. This proactive approach demonstrates a clear commitment to maintaining a technological edge and ensuring that the U.S. military can adapt quickly to changing threats on the global stage. Following the announcement, companies involved in the NGAD fighter competition are speaking out with clear messages about their visions for the future of U.S. air power. Lockheed Martin, the losing bidder, quickly released a statement to TWZ. They said, "Lockheed Martin continues to work to advance critical technologies to outpace emerging threats and deliver true 21st century security solutions to our nation's military forces. We are committed to advancing the state-of-the-art in air dominance to ensure America has the most revolutionary systems to counter the rapidly evolving threat environment. While disappointed with this outcome, we are confident we delivered a competitive solution. We will await further discussions with the U.S. Air Force." That final line hints at a possible protest against the contract award, showing that the battle is far from over. Engine manufacturer General Electric also joined the conversation with a post on X. Their message expressed their gratitude for the administration's leadership and reaffirmed their commitment to keeping U.S. military air superiority strong for decades to come. GE mentioned how excited they were to see the NGAD program move forward and looked forward to the opportunities it could offer to power the fighters of the future. This sentiment follows recent moves where the Air Force increased contract ceilings with both General Electric and Pratt & Whitney to $3.5 billion. Those funds will support further work on prototype next-generation jet engines under the Next Generation Adaptive Propulsion (NGAP) program, a crucial component to power the NGAD fighter. Although the future of the NGAD combat jet is still taking shape, the NGAP program is poised to have a major impact on other advanced aviation projects as well. Boeing, clearly the big winner in this contest, is making headlines for its clean sheet approach to fighter design. John Ostrower, editor-in-chief of the Air Current, pointed out that this is the first time Boeing has secured a contract for a completely new fighter jet built from scratch. In the past, Boeing's successes in the fighter market were tied to designs inherited from McDonnell Douglas, like the F-15, AV-8B, F/A-18, and EA-18. This victory with the F-47 marks a turning point for Boeing, as it shows the company is ready to innovate without relying on past templates. Their approach with the F-47 leverages decades of aviation expertise, combined with a fresh perspective on modern combat needs. The next phase for the F-47 program, as outlined by the Secretary of the Air Force Public Affairs, will kick off the Engineering and Manufacturing Development, or EMD phase. In this stage, Boeing will focus on maturing, integrating, and testing all components of the fighter. A small number of test aircraft will be built for evaluation, and the contract includes options for low-rate initial production. This means that after the rigorous testing phase, there will be room to gradually increase production, ensuring that the new fighter can be fielded effectively once it meets all performance and safety requirements. Steve Parker, Boeing's interim president and chief executive officer of its Defense, Space and Security Division, issued an official statement that summed up the company's excitement and determination. He said, "We recognize the importance of designing, building, and delivering a sixth-generation fighter capability for the United States Air Force. In preparation for this mission, we made the most significant investment in the history of our defense business, and we are ready to provide the most advanced and innovative NGAD aircraft needed to support the mission." Parker's words underline not just a commitment to winning contracts, but a deep belief in the power of innovation to redefine the future of air combat. As these statements roll in, it's clear that the race for air superiority is not just about one contract or one company. It is a complex competition that involves many players, all driven by the same goal: to keep America's skies safe and to ensure that the U.S. military remains on the cutting edge of technology. The NGAD Fighter Initiative is a perfect example of how collaboration, competition, and innovation come together in the world of defense. While Boeing takes the lead with the F-47, the ongoing efforts by Lockheed Martin, GE, Pratt & Whitney, and others are just as critical to shaping the future of air combat. In short, the next steps in the NGAD program are set to bring exciting developments to the forefront of military aviation. With the F-47 entering its EMD phase and vital engine programs moving ahead under NGAP, the stage is set for a dynamic evolution in how the United States defends its airspace. As we watch the F-47 take shape and the future of air combat unfold, one question remains: will Boeing's next-generation fighter truly redefine the skies, or will its rivals find a way to catch up? Sweden has gone from a neutral country for over 200 years to a NATO hardliner in no time flat. Once known for staying out of global conflicts, Sweden is now fully stepping into the military spotlight, and it's not doing it quietly. With NATO membership secured and eyes on Russia's aggression, Sweden is ramping up its defense game. At the center of this shift, a $30 billion arsenal of cutting-edge weapons, including F-35 testing and some of the country's most secretive military tech. Why has Sweden changed course so fast, and what are they preparing for? Join us as we explore the details of the 30 billion secret weapons that Sweden is testing on the F-35. While the world's attention is on the billion-dollar defense projects from the US, UK, and France, like America's NGAD or Europe's Future Combat Air System, Sweden is quietly moving ahead. And if history is anything to go by, when Sweden moves in the aerospace game, it tends to be years ahead of the pack. Sweden isn't new to advanced aviation. From the early Cold War days to the present, it has consistently punched above its weight. At the center of this quiet revolution is Saab, a defense and aerospace company with a long track record of innovation and bold engineering. While bigger nations drown in delays and rising costs, Saab is focused, precise, and surprisingly fast. Right now, Saab is pushing into the future of air combat with concepts that many other nations are only starting to talk about. Leading this effort is a focus on manned-unmanned teaming, where fighter pilots fly alongside intelligent drones that support, scout, or attack. This technology could change everything about how wars are fought in the sky, and Sweden is already testing real systems. Then there's stealth. While the world obsesses over radar-evading shapes and coatings, Sweden is taking a smarter, more holistic approach. Rather than just hiding aircraft from radar, they're focusing on making planes that operate in silence, jam-proof, low signature, and able to manage their own electronic footprint with precision. It's not just about avoiding detection, it's about owning the digital battlespace. And speaking of digital, one of Sweden's biggest strengths lies in data sharing. Saab has developed some of the most advanced data fusion systems in the world, technology that connects fighters, drones, ground teams, and even naval units in real time. It gives pilots and commanders a complete picture of the battlefield, with information flowing smoothly and securely across every platform. It's so advanced that it would likely make even seasoned U.S. Air Force officials rethink their current systems. What makes this all the more impressive is the speed and cost-effectiveness of Sweden's progress. While larger powers debate budgets and argue over delivery timelines, Sweden is quietly building, testing, and fielding next-generation systems. They're not waiting for the perfect solution, they're putting real technology in the hands of real pilots right now. Ask any expert in modern air combat, and they'll tell you that today's battles aren't just about who has the fastest jet or the most powerful missile. It's about who controls the information. The winner is the side that sees the battlefield first, shares data faster, and makes decisions in real time. In today's high-speed wars, even a 1-second delay can mean the difference between dominating the skies or losing everything. And this is exactly where Sweden stands out. While bigger countries are just starting to realize the power of information-driven warfare, Sweden has been working on it for decades. In fact, Sweden's focus on networked air combat goes all the way back to the Cold War. Surrounded by bigger and more powerful nations, including the Soviet Union, Sweden knew it couldn't win with brute force. So instead of building huge fleets or massive bombers, they got smart. They focused on speed, awareness, and communication. This smart approach has shaped Sweden's defense strategy ever since. Instead of relying on raw firepower, they built aircraft and systems that talk to each other, share battlefield information instantly, and help pilots and commanders react faster than anyone else. While other nations were focused on stealth coatings and supersonic engines, Sweden was laying the groundwork for the future of warfare: fast, secure, and flexible data networks in the sky. Today, that early work has paid off. Saab, the Swedish defense giant behind much of this innovation, has developed some of the most advanced data fusion systems in the world. Their fighter jets, especially the Gripen, are famous for being able to collect information from multiple sources, process it instantly, and send it across to other jets, drones, or even ships and ground teams. This creates a real-time picture of the battle that helps everyone move like one powerful unit. And the best part? It's all built with simplicity, speed, and survival in mind. Swedish systems are known for being fast to deploy, easy to update, and tough enough to survive in rough environments. In short, they're not just designed to work, they're designed to win. As other countries rush to catch up, investing billions into digital command centers and AI-assisted warfighting, Sweden is already years ahead. Their networked warfare tools aren't experimental or stuck in planning. They're real, they're tested, and they're already flying. In the world of modern air power, it's no longer just about who has the best plane. It's about who knows the most, acts the fastest, and moves as one. That's Sweden's strength. They've turned information into a weapon, and they've been doing it long before it became the trend. By the 1980s, Sweden was already rewriting the rules of air combat. While most countries were still focused on brute force and radar lock-ons, Swedish pilots flying the F-47 Viggen were doing something no one else could match: silent, radar-free missile strikes using shared sensor data. Two Viggens could fly nearly 40 miles apart and still operate as one, combining their radar information without broadcasting any signals. This meant they could track and engage enemy aircraft without lighting up on enemy radar. In combat terms, that was like being invisible, seeing your opponent before they ever knew you were there. Even more impressive, a four-ship formation of Vigans could know the exact position, fuel levels, and remaining weapons of every aircraft without ever speaking over the radio. It was pure battlefield stealth, no emissions, no chatter, just smooth, quiet coordination. Back then, it was a level of electronic warfare decades ahead of its time. For comparison, the United States wouldn't have a fighter with similar data-sharing capabilities until the F-22 Raptor entered service in 2005, a full 2 decades later. But Sweden didn't stop there. The next leap forward came in the 1990s with the birth of the JAS-39 Gripen. Saab, Sweden's legendary aerospace firm, took everything they learned from the Wagen and upgraded it. The original Gripen came standard with a built-in data link, allowing pilots to instantly share targeting info, sensor readings, and mission updates in real time. This wasn't just a fighter, but a flying network node. Then came the Gripen EF, the latest and most advanced version. This aircraft doesn't just communicate, it thinks as one. Every pilot in a Gripen EF formation sees a unified combat picture thanks to real-time sensor fusion and high-speed data sharing. Each Gripen EF has more than 40 antennas wrapped around its body, giving it 360-degree passive detection. Together, a group of Gripens acts like one massive floating sensor. Every jet gathers, processes, and transmits terabytes of information during flight, building an ultra-clear picture of the battlefield. Even better, this data is automatically fused and distributed across the group. That means every pilot sees what every other pilot sees. No lag, no confusion, and no wasted time. In a fight where speed, stealth, and information are the real weapons, Sweden's quiet innovation has given them a major edge. While global powers pour billions into experimental programs, Sweden already has battle-ready jets doing what others still dream about. The photo above captures one of these jets in action, a JS-39C Gripen, sleek and lethal, slicing through the sky with precision. But behind that dramatic image lies something even more powerful, a legacy of smart design, quiet superiority, and a deep understanding of how tomorrow's air battles will really be won. And here's where things get even more fascinating. Sweden didn't just design a smart fighter jet, it designed one that makes decisions for the pilot. According to Saab operations advisor Jussi Halmetoja, pilots flying the Gripen aren't expected to micromanage every radar or sensor setting. Instead, they're trained to trust the system. Rather than adjusting radar modes or tracking targets manually, the aircraft's AI-powered sensor fusion takes control. It analyzes every radar return from the full formation and automatically assigns targeting tasks to the jet best suited for the job. That means if one Gripen has the clearest lock, it takes the shot, while the others stay hidden or prepare for support. It's quick, smart, and eliminates the fog of war. For the pilot, this reduces stress and allows full attention on tactics, decision-making, and mission success. In short, Sweden built a fighter jet that thinks before it shoots. And the story doesn't stop there. While this kind of advanced decision-making is already changing how manned fighters operate, Sweden's real goal is much bigger: to apply this technology to drones. That's right. Sweden is now integrating the Gripen's brainpower into an upcoming ecosystem of uncrewed aircraft. Saab's vision is a distributed combat network where manned jets and drones fly together, sharing sensors, jamming enemies, and launching coordinated strikes with minimal human direction. This isn't just a blueprint or lab experiment. Saab has been testing AI-assisted autonomous flight for years. In 2023, they made a bold move by acquiring Blue Bear, a British company that specializes in drone swarm coordination. That's a big hint. Sweden isn't just playing catch-up. They're building an air force where drones and jets work as one unit. The key takeaway? While the United States and its allies spend years debating how to bring drones into combat squadrons, Sweden is already designing a future where data is the main weapon, not just the aircraft that carry it. Sweden's decades of quiet innovation, digital integration, and electronic warfare have built something special, an air force that doesn't just fly. It thinks, adapts, and evolves. From the cold skies of the Cold War to today's digital battlefield, Sweden has gone from a neutral observer to one of the smartest players in the sky. For decades, fighter jets dominated the skies. Human pilots, strapped into multi-million-dollar cockpits, made life-or-death decisions in a matter of seconds. But the battlefield has evolved, and the era of manned-unmanned teaming has officially arrived. The thinking is simple. Why risk a highly trained pilot when a drone can do the same job, sometimes better? Instead of sending one $100 million fighter into enemy territory, you can now launch a fleet of smaller, affordable, and highly capable drones. These drones can overwhelm enemy defenses, gather live intelligence, and even strike targets, all while keeping human lives out of harm's way. This isn't a vision of the distant future, it's happening now. While many countries are still drawing up blueprints, Sweden is already engineering the next generation of air combat. Saab's latest plan is to create a hybrid air force, where manned and unmanned aircraft work in seamless harmony. Gripen pilots won't just fly with human wingmen. They'll command swarms of autonomous drones that extend their line of sight, boost their firepower, and carry out complex missions that once seemed impossible. In this new combat structure, stealthy drones slip quietly into hostile airspace without being noticed. Others are designed to jam radars and scramble enemy sensors, throwing off missile guidance systems and disrupting defenses. Some drones are programmed to act as loyal partners, flying alongside Gripen fighters while carrying additional missiles and advanced tech. There are also expendable kamikaze drones, designed to dive straight into high-value targets. They take the risk no pilot ever should, proving that sometimes the best way to win a dogfight is to send a machine, not a man. And this isn't just theory. Saab is already testing these technologies. In 2023, they acquired Blue Bear, a UK company that specializes in drone swarm coordination. It was a clear signal. Sweden isn't just thinking about the future, they're building it. What sets Sweden apart is their head start. While others are scrambling to connect drones with jets, Saab is building on decades of experience in digital warfare. The Gripen is already a flying network, able to share data and sensor information with precision and speed. Now that same battlefield intelligence is being extended to uncrewed systems. This changes everything. The fight is no longer about a single aircraft. It's about the collective force, a tightly connected swarm that sees more, moves faster, and strikes harder. Pilots become mission commanders, managing both jets and drones from the cockpit. Drones become the eyes, ears, and even the fists of a new kind of air force. As other nations debate policies and run simulations, Sweden is out in front, quietly training for tomorrow's wars today. The world's most advanced air combat might just come from the country that always preferred to fly under the radar. Much of Sweden's drone development remains behind closed doors, but key moves in recent years give us an exciting glimpse into what's coming next. In 2023, Saab made a strategic move by acquiring Blue Bear, a British tech company known for its cutting-edge work in AI and drone swarm coordination. This wasn't just a business deal, it was a message. Blue Bear is one of Europe's top players in uncrewed systems, and its deep expertise in autonomous flight and networked drone behavior fits perfectly with Saab's long-term vision for future warfare. Later in late 2024, Saab revealed early concept images for a sleek, uncrewed aircraft. Observers quickly noticed it bore a strong resemblance to the iconic Cold War-era J-35 Draken. If Saab is indeed drawing from the Draken's legacy, expect something fast, agile, and purpose-built for dangerous contested airspace, only this time without a pilot. Meanwhile, the Gripen EF continues to prove that it's more than just a fighter jet, it's a battlefield brain. This version of the Gripen is equipped with a highly advanced sensor fusion system, capable of combining and sharing live data with other aircraft in real time. Now imagine linking that brain to a group of autonomous drones. A single pilot could guide a small fleet of uncrewed aircraft, coordinating strikes, directing surveillance routes, or even allowing them to react independently to real-time threats. Sweden has also been experimenting with turning parts of the Gripen's electronic warfare suite into deployable decoys. This means uncrewed drones might soon act as flying shields, jamming enemy radar, confusing targeting systems, and creating a fog of war that keeps piloted aircraft safer. These drones wouldn't need to survive long. They just need to protect their crewed counterparts and make the enemy's job harder. Unlike some countries trying to fully replace human pilots, Sweden's goal is smarter: boost the pilot's capabilities, not eliminate them. The idea isn't about choosing between man and machine. It's about blending them into one powerful, adaptive force. The future of air combat, according to Sweden, is modular and flexible. It's about sending the right mix of machines and people depending on the mission, the risk, and the enemy. And frankly, it's a strategy that makes sense. While global powers like the United States, China, and Russia race to build their own loyal wingman drones, Sweden has already been developing, testing, and integrating such systems for years. Even in stealth technology, an area usually dominated by big names like the F-17 Nighthawk or the B-2 Spirit, Sweden has long played the game, just without the spotlight. Saab has been crafting radar-evading systems and electronic deception tools since the Cold War, always focused on blending cost efficiency with operational punch. Rather than pouring billions into massive stealth bombers, Sweden refined a smart approach that blends low radar visibility, powerful jamming tools, and networked deception. And here's the secret: it works. Most people think stealth technology began in the United States during the 70s with Lockheed's top-secret Skunk Works projects. But few know that Sweden was already exploring radar and visibility a full decade earlier. In 1963, Bill Barrett, a United States Air Force engineer who specialized in stealth, quietly traveled to Sweden. His mission was highly unusual for the time: help Saab reduce the radar signature of its upcoming F-47 Viggen fighter. At that time, the concept of stealth was still in its infancy. The F-17 Nighthawk wouldn't fly for years. And yet Sweden was already working on radar cross-section reduction. The result of that secret collaboration was the Viggen, introduced in 1971. Though it was never marketed as a stealth aircraft, the Viggen featured subtle design elements that helped it avoid detection, decades before stealth became a military buzzword. This foundation laid the groundwork for what Sweden would later perfect in the Gripen. While American stealth jets, like the F-22 and F-35, depend heavily on shaping and expensive radar-absorbing coatings, Saab's approach is more balanced. The Gripen's design includes reduced radar visibility, but it also leans on smart tactics, passive sensors, and powerful jamming technology. Although Saab has never publicly released the radar cross-section of the Gripen, the E and F variants are believed to include features like edge alignment, radar-absorbent materials, and an airframe built to minimize radar reflections. But the real secret lies in the Erexus electronic warfare system. This system uses phased-array gallium nitride antennas to jam enemy radars, mislead missile seekers, and cut off hostile communications. It makes the Gripen nearly untargetable in contested airspace. Saab has even tested parts of the Erexus system on expendable drones and decoys. This allows Gripens to send out electronic false signals, making it nearly impossible for enemies to know what is real and what isn't. The jets also use passive sensors to track infrared signatures and electronic emissions, watching silently instead of broadcasting radar pulses. That means the enemy lights up on radar, while the Gripen remains hidden and shares real-time targeting data with nearby aircraft. What truly separates Sweden is its independence. While other countries form massive multinational alliances to build next-generation fighters, Sweden has chosen to go it alone. It turned down partnerships in both the UK, Japan, Italy Global Combat Air Program and the French, German, Spanish Future Combat Air System. Instead, it's focusing on developing core technologies at home, on its own terms, without outside delays or compromises. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.